I was trying to tell kids in my other class, is some of you think you know, and so you work ahead. It's going to hurt you if you do that. All right, I'm going to teach you about, it's called the fundamental counting principle. All right, and the person who finally figured all this stuff out made an amazing contribution because they've been working on it for a long time. All right, now I can't believe that it was this hard to figure it out, but you have to remember, a long time ago, all right, they weren't sure how things worked. All right, so this discovery really helped. All right, and it's called the fundamental counting principle. Now, the first thing that we're going to show you, though, Sean, come on, we're in 8th grade. Come on, get a pencil out. We're copying notes. All right, tree diagrams are used to illustrate the total number of possible outcomes. And you're not supposed to know that. I'm going to show you that, and you go, okay, that's what he means. All right? Tree diagrams are used to illustrate the total number of possible outcomes. And that's not going to be on the test either. All right? That's just something you should know. All right? The next thing, a tree diagram is a graphical way to show all possible outcomes in a situation or an experiment. And I'll show you that too. All right? And then finally, all right, the sample space. I don't know why they call it a sample, because it seems as though if you take a sample, you're taking part of it, right? But that's not what a sample space actually means. The sample space is the set of all possible outcomes in a probability experiment, all right? The set of all possible outcomes in a probability experiment. That's what I want you to know. That's what I want you to write down, all right? That's the important part. Now, in a minute, the tree diagram looks like, you know, when I first started teaching this, I didn't do the tree diagrams because I thought they were simple and easy, and I thought kids were bored with them. But then I realized that if you don't do the tree diagram, you don't understand the numbers as well and why the numbers work this way. All right? So I want everybody to please pay attention. All right? Try not to go ahead. All right? Try to work with me. Fill in when we can. I'm going to add some information, all right, that will help you understand it better. All right? So now, with that being said, what we're going to do now is we're going to flip a coin. No, just wait. That's what I'm saying. I'm not sure what's taking you so long. All right? Well, you're going to keep up, right? That's what you're going to do. All right? So make yourself a note. Come after me. Ask after class, and I'll fill you in with what you missed. All right? We're not bothering other people. All right? Now, we're going to flip a coin. We're going to flip a coin twice. All right? What we're creating right now is the sample space. And the sample space is just a list of all the possible outcomes when I flip a coin. All right? So most people would be able to tell me if I flip a coin 2 times, how many outcomes are possible? How many possible outcomes? 2. What do you think? 2. What do you think? Some of you are not thinking. How many? 2. How many? 3. Good. How many? 4. What do you think? 2. Good. 2. 8. Good. 3. No, you don't need an explanation. Sean. 8. Good. Xavier, you finally thought about it. How much? 4. 3. Good. All right. Sit down. Nope, you're not allowed up. Come on. I mean it. I'm really working on you guys. All right. You're not going to disrupt the class anymore. We're going into Algebra 1. You're going to learn to sit and stay focused. All right. And work with me. I know you did, but have 2 then. And then when it falls on the floor, you won't have to make a scene. All right. Now we're going to figure out the answer. All right. We're going to figure out the answer. So when you flip a coin, all right, you have a possibility of getting a what? Heads or a tail. Right? Then you're going to flip it again. Right? You have the possibility of getting a what? Heads or a tail. So here's what we're talking about. If I flip a coin, the first time I flip it, it comes up heads. The second time I flip it, it comes up what? Heads. Now, how you're creating the sample space is by going through all stop interrupting. I'm not doing it anymore. You understand me? Leave him alone. I've got him situated. He made an A on his last test. I don't need you messing with him. You hear me? Simple as that. That's fair. All right? Now, again, is that the only possibility? No. I could flip the coin and get a heads. And then if I flip it again, this time instead of being heads, heads, it could be what?
Heads, tails.
Heads, tails. So this could be tails. Now, is there another possibility that can occur if I flip the coin and the first time I get a heads?
Yes. Or no.
Yeah, come on. That's what I'm saying. You got to listen to my question. Come on. Same thing. Let's go. Chop, chop. Interrupting. Getting up out of your seat. Come on. What do we need? All right. That's all right. Come on. You know I'm not fussing at you guys. We're working on it, though. All right. I want you to be ready, prepared when I start my lesson. All right. There you go. You're good. I'm not fussing. I'm just trying to get you. Same for girls as for boys. All right. Be ready. All right. Now, I could get heads or tails. All right. Is there another possibility that could be affected if I flip a head the second time? Is there another possible outcome? No. All right. So I've exhausted all possibilities when I flip the first coin that comes up heads. Everybody agree with that?
Yes.
All right. Now, the other option is when I flip it, it becomes a what?
Tail.
Tail. So I want everybody to put tail here. All right. Now, when I flip the tail, the second time I flip it, it could be a what?
Heads.
Heads. So now we put heads here. Now, is that all the possibilities?
No.
No, because I could flip it, and the first time it becomes a what? Tail. The second time it could be a what? Tail. Now, stop talking. Now, just give me a second to finish. I don't need any help right now. I'm going to ask the questions. Now, is there another possibility that could occur in flipping this coin twice? What is the other possibility then? I'm listening. All right, that's what I'm saying. Pay attention. All right, is there another possible outcome? If you think there's another possible outcome, I want to know what it is. And the answer, of course, is what? No. So the outcome would be H, T, T, H, or what? T, T. This right here is called the sample space. That is called the sample space. That is the entire possible outcome of flipping two coins. What?
Aren't two of them the same?
No, they are not. They are not the same. All right, definitely not the same. Eve, what do you need? Tell me. Okay, so listen to me. Please don't be upset. All right, I'm not trying to be. I just want you to ask me. Okay, please ask me. All right, don't worry. You are always great.
Oh, no,
Okay. All right. Well, just tell me. Hey, I can't see. You hear me, Eve? I promise you. All right. Don't. Come on. All right. Here we go. Is that better? All right. Here we go. That's the possible outcomes right there. That's it. All right. Those are the 4 possible outcomes. So those of you guys who said there were 4 outcomes, that's it. 4 outcomes. All right. Now what I'm going to try to do is I'm going to try to show you how people, like I have this all organized in my head. I'm going to try to teach you how to organize numbers in your head so you can list all the possible outcomes quickly. All right? That is the importance of a what? Tree diagram. That's the importance of a tree diagram. I'm going to ask you in a few minutes, what are the possibilities of flipping 3 coins? And what are the possibilities of flipping 3 coins? And how many are there? How many possibilities are there? 12. How many possibilities are there when you flip 3 coins? 9. Good. What do you think? What do you think? 9. What do you think? 9. What are you thinking? 9. After today's lesson, you are going to know exactly, and you're going to be able to rattle off all 8 possibilities. You're going to be able to rattle off all 8 possibilities quickly. If I said, what are the possible outcomes? List them for me. And I told you there were 8 possible outcomes. How many of you do you think you could write down all 8 possible outcomes? It'd be kind of hard, wouldn't it? Because you don't know the pattern. You do not know the pattern. And some of the numbers are actually even what? Repeated, right? Because you could be head, tail, head, or head, head, tail. Does everybody agree with me? Right, so in a minute, I'm going to show you how you can start listing things out, and you'll be able to recognize the patterns so that you will be able to be an expert at all these numbers. All right, so here we go. The tree diagram starts like this. And again, we start out simple, and then we go to easy. All right, we start out simple, and we go to easy. All right, so here we go. Flip 1. Here we go. Flip number 1. Flip number 1. All right. What are my possible outcomes?
Heads, tails.
Heads, tails.
Tails.
Heads or tails? Jensen, see what I'm talking about, right? That's why I'm begging you guys. You all right?
That's scary.
Shh, I know. It is very scary. All right? That's why I'm saying, boys, don't lean back in your chair. All right? That's a second person who's flipped on their chair. Leave your desk alone. Sit on the desk. Yes, leave it there. I know you guys think I'm like being an ogre or something. I'm not really. It's because those types of things happen. And like I said, if you fall over and you crack your head open and you start bleeding all over the place, your parents aren't going to care what I did or didn't do. They're going to blame me. That's what I'm saying. Don't do it. I'm not trying to be mean. All right? Your parents care if you come home with stitches in your head. And it's going to be whose fault? My fault.
It's
All
not.
right? It is. It doesn't matter what you say. All right? Your parents aren't going to care what I say. They want someone to pay because you got stitches in the back of your head. All right? Now, everybody see, people flip twice in this class now. All right? Jack, you think you're funny. I don't want to hear it out of you. Just zip it. People are tired. Now, flip 1, heads or tails. All right, that's how we're doing the tree diagram. All right, now, here's where the branches come in. All right, so flip number 2. What can I get on flip number 2? A what? Heads or tails. So watch this. H or a what? H or a T. Now what here? Branches out again. Now it could be a what? Now we're going to stay consistent because I heard somebody say TH. Is it okay to do TH? Yes. But if you stay consistent, it'll be easier for you to organize the numbers in your head. So this is going to be a what? HT. All right. So now how many outcomes were there? Total. How many outcomes were there total? 4. How do we know there's 4? So watch, guys. There's 1. So what's the first possible outcome? HH. What's the second outcome? HT. What's the third outcome? TH. And then what's the fourth outcome? There you have it. TT. All right. So how many outcomes were there? 4. So then this guy realized, wow, what's the relationship between the number of flips? Watch this now. Everybody put this down at the bottom of their screen. How many times did we flip it? 2 times, right? So the first time you had a what? Heads or a? Second time was what? Heads or tails. Now, I can expect you to make a mistake here. So what's the relationship? Come on now, try to think about it. What's the relationship with these 2 numbers and how I get to these outcomes? What do you think I do? Tell me. Yay, that's exactly what he figured out. The fundamental theorem of, just the fundamental counting principle just says whatever many outcomes you have, you just multiply them together, and that gives you the total number of outcomes. So this right here, relationship, is a multiplication sign. So we know there are 4 possible outcomes. And I was telling the people in the last class, does everybody know the lottery, right? You can win like whatever, $450 million or whatever it is. So you select these numbers, and then you have a chance of winning 450 million. Does everybody agree with that? But again, how do you think they figured out the odds or the chances of winning? Yeah, it's a fundamental counting principle. That's what we're going to show you. So we can actually, hopefully at the end of the lesson, I can teach you how they came up with these numbers. All right? And then, well, I'll show you how you can, well, I'll show you stuff about the lottery. All right? I'll tell you things about the lottery. But right now, this is called the fundamental counting principle. And before I said I didn't teach the kids the tree diagram, but then they didn't understand how or why I just multiplied the numbers. So now, just to make it crystal clear, at the bottom of your page, right here, right under example 1, you're going to flip a coin 3 times, and you're going to write the tree diagram for me. And when you write the tree diagram for me, how many outcomes are there going to be for flipping a coin 3 times? How many? No, you're not listening one bit. How many outcomes are possible when you flip a coin 3 times? 8. You are brilliant. Thank you for listening. So now you're going to figure out why it's 8. So everybody draw a tree diagram. All right, give you like 30 seconds. All right? You're going to flip it. That's exactly right. You're going to flip it 3 times. So you can look back at your notes and say we just flipped it once, then we flipped it twice, then we flipped it 3 times. So you have to draw the tree diagram for that. All right, and again, I used to not do this, and then kids didn't really understand. All right, so this is a tremendous help visually of why there are 8 possible outcomes. Why there are 8 possible outcomes. All right, so here we go. Wow, that's good. Now, when you're doing the tree diagram, though, I want to try to show you one little thing here. I almost prefer that you say this is flip 1, and on flip 1 you can get a what? Heads or tails. So watch. I prefer that you're going down the page this way, heads and tails, right? Now, flip 2 generally goes on the top, all right? So if I'm doing flip 2 now, all right, you're going to branch this off into what? HT, that is correct. Thank you for listening. And then this tail down here breaks off to what? HT. There you go. Now we're on flip what? We're on flip 3. Now this branch up here can branch off to what? HT. And then the next branch is what? HT again. Come on, guys, stay with me. And then the next branch, HT. And then the last branch. Now, believe it or not, that was revolutionary when they figured that out. All right, to me, it's not a big deal, right? But a long time ago, that was a big deal. All right, what? Listen to me. Yes, I said go to the bottom of the page. I'm changing it up. I want you to do at the bottom of the page 3 coins. That's what I said. All right? Here we go. Now, how many outcomes were there, did we say? 8. So let's count them. So I'm going to count them, changing this. Here's 1. Here's 2. Here's 3, 4, 5, 6, 7, 8. You with me on that now, right? Now, what is the first outcome, Sean? I don't even see a B anywhere on here.
Talking about the answers.
Why are you answering for him? I'm asking Sean a question and you're answering for him. What is our first outcome? H 3 times. All right? Because how did we know that? Because watch, guys. Here's how you do the tree diagram. H, H, H. So the first outcome is H, H, H. All right? Tucker, what's the second outcome?
HHT.
Yes. All right. I'm happy with you. H, H, T. Now again, just to make sure you're seeing me, H, H branched off to T because I couldn't go any higher. That's what I try to show kids. All right? Now, I need the third branch. The third branch, what is it? Yes, HTH. Now I think we're listening. All right? Fourth branch. HTT. Now, have we exhausted everything where the heads is first? Yes. Now, fifth branch. THH. Nope. Sixth branch. Tell me. Shh. THT. Seventh branch. Seventh branch.
Oh wait, no. TH.
Yes. And the last branch. Tell me. Yeah, TTT. Now again, believe it or not, I can rattle those off so fast. Because why? I have it organized from the what? The tree diagram. All right? Now, if I added another branch, let's say there were 4 flips. How many outcomes are there going to be now? 16 outcomes. That's exactly right. Do you think you could list all 16 now? Yeah, it would be super easy. It would be super easy if you draw a what? If you draw the tree diagram. That's exactly correct. All right? Yes, ma'am. Yeah, it is. Well, some people, it's easy to keep things. You know what I'm saying? I'm not that good. I'm good when the numbers are smaller. Like I could list those out easily. Right? But now adding the fourth branch, it starts to get a little bit harder. All right. So again, it's much easier if you would do it what? Just on a piece of paper. And you can see how easy it is to identify the outcomes. But again, most people cannot do that. All right. Most people can't identify the possible outcomes. All right. Yes.
What is, because last time there was a relationship. Now what's the relationship?
It's the same thing. How did we come up with 8? How many times did we flip the coin? So everybody do this. All right. How many possibilities are there for the first coin? 2. How many for the second?
4.
How many for the second?
Oh.
2. How many for the third?
2.
And what's the relationship?
They're all up.
Yes, here we go. We're multiplying.
2 times 2 is 4 times 2.
Yes, that means there are 8 different possibilities. Hey, same thing. We're not. Every time you're gonna be silenced. All right, put your hand up and raise. And we'll talk. All right, there are 8 possible outcomes. What? All right, thank you. All right, now what I want to do is I want to go back to our original. All right, now I want to talk about question 1 and 2. Try to think back here. All right, what is the probability of getting tails on both flips? E, what's that probability? Well, tell me, look.
Just getting 8 tails or like?
Now look here. It says, I'm going back up to here, not to the original. So what is the probability of getting tails on both flips? Now, how many outcomes were there on this one? Tails on both flips, though. How many is tail? Yeah, you would say 25%, but more importantly, generally probability is done as a what? Fraction. Yeah, so you would just say 1 out of 4.
I thought it was asking like just to get like 8.
Nope, that's the next question, actually. All right.
No.
The next question, Gray, is what?
1 5 at least 1,000.
3/4. Now, again, some of you are saying 75%. Do I really care? No, but probability is generally done as a what? Fraction. Yes, ma'am. How I got 1/4 or 3/4. All right, so let's take a look. All right, well, here's our outcomes, right? How many of those 4 outcomes have both tails? 1 out of 4. Well, how many of them have at least one tail? That's it. That's how simple. 3 out of 4. All right. So that's why question number 2 was what? 3 out of 4. What time is it, Dolly?
45.
45. All right. Now, let's take a look quickly at example 1. All right. And I know I kind of made you write in there, but I'm just going to circle mine. All right. And we're going to talk about that real quick. So it says, a family has 2 children. Draw a tree diagram to show the sample space of the children's genders, then determine the probability of a family having 2 girls. Is there really any difference between the genders and flipping a coin?
No.
No. So who can tell me right off the bat, what's the probability of getting 2 girls? What?
1/4.
1/4. What's the probability of getting 2 boys? What's the probability of getting a boy and a girl?
2/4.
Yeah, 50%. Because, again, here's how you're thinking about that. It could be a girl and then a what? Boy, or a boy and then a what? Girl. That's exactly correct. All right? So, again, it's the same situation because there's only 2 possible outcomes. All right? Now, again, it would be interesting. Is there really any difference if I said 3? If you had 3 kids, what is the possibility of getting all boys or all girls, or a boy, girl, or 2 boys, and something along those lines? Does everybody agree with me right there? So it's, again, just listing them all out as a tree diagram, and it's super, super simple once you learn that technique. All right? Is everybody okay with that? All right? Any questions? All right? So now, honestly, the only thing I want you to do now for homework is I want you to take your test out. I want you to kind of look it over. All right? I want you to try to make some corrections if you made a mistake. All right? I'm not answering your questions. If you want to ask help from your neighbor, say, hey, I only missed this one. What did I do wrong? If you can't figure it out, that's fine. Don't be embarrassed about your grade. Fix your mistakes. That's what your job is. Try to fix your mistakes.